All right, let's get right into it. You've heard about these massive, super powerful AI models like GPT-3, right? They're incredible, but they're generalists. What if you could take one of these giants and give it a very specific, expert skill? Make it a master of your field, without having to rebuild the whole thing from scratch? Well, that's the huge idea we're going to unpack today.
So, let's just put ourselves in that situation. Imagine you're a company or a researcher, and you want an AI that really truly gets your legal documents, or your specific medical data, or even just your company's unique codebase. How do you even start to do that? Well, the old way, it presented this huge, almost impossible problem.
And that problem? It all starts with scale. Just the sheer, mind-bending size of these AI models. Look at that number. That's how many parameters are in a model like GPT-3. You can think of each one as a tiny little knob that gets adjusted when the AI learns. And we're not talking thousands or millions. We're talking over 175 times billion of them. It's a number so big, it's kind of hard to even process.
And all those billions of knobs, they take up a ton of space. A single GPT-3 model is about 350 gigabytes. Now, just to put that into perspective, if you wanted to make, say, 100 different specialized models the old-fashioned way, you'd be looking at 35 times terabytes of storage. That's just massive. So here's the bottom line. The traditional way to do this, called full fine-tuning, meant you had to take that whole 350 gigabyte model and then retrain all 175 billion of those parameters on your specific data. And every time you did it, you'd create a brand new, equally gigantic copy. As you can imagine, this was ridiculously expensive, super slow, and for most people, completely impossible. There just had to be a better way.
And thankfully there was. That better way came from this really brilliant insight, a total revelation about how these models actually learn something new.
So researchers started digging into this idea called intrinsic rank. The thinking goes something like this. Even though the model has billions and billions of parameters, the actual change you need to make to teach it a new skill, like summarizing legal docs, might be surprisingly simple. The complexity of the update is way, way smaller than the complexity of the entire model. And this right here, this is the aha moment from the original research paper by Microsoft. They basically said, hey, we're betting that the package of changes you need to make doesn't have to be this huge, complicated mess. We think it can be represented by something much, much simpler, a low-rank structure. They made a bet that the necessary change was elegant and simple, not big and clunky. And you know what? That bet totally paid off. It led to this incredibly smart solution called LoRA, which stands for low-rank adaptation. I love this analogy because it makes it so clear. Think of that giant AI model as a massive, super powerful car engine. Full fine-tuning is like ripping out the whole engine and building a new one just to race on a different track. LoRA? LoRA is like installing a tiny, specialized tuning chip that just tells the original engine exactly how to perform on that new track. So much smarter. So how does this tuning chip actually work? It's a beautifully simple three-step process. First, you take the original model and you freeze it. None of those 175 billion parameters get touched, not one. Second, you inject a couple of really small new matrices into the model. These are your LoRA weights. And third, this is the key. You train only those tiny new matrices. That's it. The main engine stays the same, you just tune the chip.
And this slide just lays out the difference perfectly. Full fine-tuning, it retrains everything and spits out another 350 gigabyte monster. LoRA, on the other hand, freezes the original and just adds this tiny little file, often around 35 megabytes. That's not a typo, megabytes. We're talking a 10,000-fold reduction in size, which, of course, means it needs way less hardware to run. The paper found it uses 3 times less of your precious GPU memory.
Okay, let's talk about the results, because this is where things get really, really cool. LoRA isn't just about being smaller and cheaper. It's about performance.
First off, a 10,000 times reduction in the number of parameters you actually have to train. Just let that sink in for a second. Instead of tweaking 175 billion knobs, you're only adjusting a few million. It's a total and complete game changer for efficiency.
Next up, a 3 times reduction in the hardware you need. And this is so important because this is what opens the door for so many more people. All of a sudden, you don't need a state-of-the-art supercomputer to create your own custom AI. It makes it accessible to way more developers, researchers, and creators.
And this one is huge. 0. That's the amount of extra delay or latency you get when you actually use the model. How? because those tiny LoRA matrices can be merged right back into the original model's weights before you use it, so it's just as fast as the original. You get all the perks of customization with absolutely no performance downside.
Now just look at this table from the paper. They were testing the AIs on turning regular sentences into database code. The old way, full fine-tuning, got a 73% accuracy. Not bad, but LoRA, training just 38 million parameters instead of 175 billion, didn't just match it, it actually beat it. It's more efficient, it's thousands of times smaller, and in this case, it was even more accurate. I mean, come on, that's the best of all worlds.
So what's the big takeaway here? What does a world with LoRA actually look like? Well, it fundamentally changes the entire game for AI development.
Suddenly, the whole paradigm shifts. You can have one giant base model that everyone shares, and then literally thousands of these little LoRA tuning chips. You can swap them in and out instantly. Oh, you need a legal expert? Load the legal LoRA. Now you need a Python coding genius? Just swap in the Python LoRA. It just crushes the cost and complexity, and it's kicking off this explosion of custom, specialized AI models.
And that leaves us with this really fascinating question to think about. You know, for a long time, the power to build these specialized AIs was locked up with just a few big companies with massive resources. LoRA showed us that the updates needed to teach these models are actually elegantly simple. It's democratizing this amazing power. So as this tech spreads, and literally anyone can build and share their own custom genius, you have to wonder, what comes next? What are we all going to create?